Okay, my friends, this just out today. Michelle Starr says that comets and meteorites could deliver the ingredients for life to oceans of Europa. Well, obviously other areas too. Where would comets and meteorites get all this biological material for the ingredients of life? Alright, there's dozens of articles about this. What does may smell like? Well, it smells like burnt or fried steak after a spacewalk. Yep, it's true. Space smells like steak. They all say the same thing. Space smells like burnt steak, gunpowder. It's all the metals that are in the blood that are roasting off in space from the biology that's there. And this is little tiny iron meteorites. All three of those are actually biology as well. Blood is iron. Blood smelts into iron as it comes through the atmosphere. Yes, biology is being delivered everywhere because all of the comets and everything I can find, comets, meteorites, they're a lot meatier than we thought. Okay, what I want you to see is they claim this is from this asteroid Ryugu. But let me just tell you something. Asteroids, comets, meteorites, all the same thing. They say some of them come from a certain area, some of them come from some other area. They're all the same thing. Comets come in close to the sun and flare off and so forth. Asteroids are just somewhere out there floating around apparently. And meteorites come in through the Earth and crash into the Earth. Now, but they're all made out of the same material. And here's the key. They went up there and took this blue and this red are from two different locations on this asteroid. And then they tested them for what the different minerals are and metals and all that in there. And all these peaks show different materials. And these are the different materials. See this Fe? That's iron. You see that Fe? That's iron. C is carbon. Si is silicon. Magnesium, so forth. Now, they're seeing, you see the red and the blue? The red and the blue, 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 red and the blue. And then here, this is the one that's got me, is there's no blue on this one. Now this is FeO2 in my opinion, probably, which means that it's the deoxygenated blood. This is FeO3, which always has oxygen in your arteries, in the red blood. Anyway, all of these things, that's all biology. And from both places in the meteorite, on the asteroid, whatever you want to call it, they were basically very, very, very similar. And these are exactly the same things that are on Comet 67P and other places they've done this spectral analysis on. Okay, this is Comet 67P. You see the iron, all the different types of iron. In your body, your blood carries oxygen. So you have FeO2 and O3 and variations of iron in your body with different amounts of oxygen in it. It's just the way your body works. It absorbs it and so forth. It spits out carbon dioxide. Hydrocarbons everywhere. CHs. Carbon, hydrogen, sodium, silicon. That's it. That's us. And it's everything there is as far as I'm concerned. Now I don't think there's anything that is not biology. Okay, that's Comet 67P. That last spectral analysis I showed you was from two samples they took. They had a lander land on there. It was called the Philae lander. This was the European Space Agency. And this is, I think it was 2014, maybe 2015. They actually came up and landed on it. I watched every little detail of it. They were wide open with their research. They showed all the chemistry. They showed all the pictures and extremely, they're right there. They're right on the surface. Now, you get any anatomist, any of them, and you ask them, what is this? What are these little things here? If he's any good, and what is this? He's going to tell you that is a bundle of muscle. And these are the little muscle fibrils. This is tendon. And this is an enthesis. Well, what is an enthesis? An enthesis is where a tendon and muscle anchor into something, whether it's bone or whatnot. Let me show you precisely what this is. there's no question that that is biological. In my mind, if you can come up with a counter argument, I'd love to hear it. Let me show you how this thing cooks off its biology, its gases. How does it form the gases? What's a comet's tail? By the way, I have shown this to several anatomists, some of the top anatomists in the world, and they agree. They can't come up with any argument. They don't want to be held name-wise to say, yeah, that's a biological body part in space. But I have been told there's no argument. Now, what is this? You see all these little flares coming up here, these little gases? And then some coming out to the side and this way and that way and this way and over this way. They're coming every different direction. And why is this gigantic monster coming out of there? Can I explain this? Absolutely I can. And why are there none coming out of here? Why is nothing coming out of here? All right? Here's why. Your body has all cells in it. And every single cell in your body has to be serviced with blood. And has to be serviced with red blood. And red blood is carried by a big artery, which is that one right there. And that big artery, and I mean, I'm going to show you what it looks like, and it's going to freak you out. That is boiling off its gases because the sun is in a direct alignment with it. And it's cooking it just like it would cook on your barbecue grill. But there's no oxygen to speak of in space, not enough to combust. So it just gases off and shoots out of here like a coma, the comet tail. And then as the comet goes past it, it sort of sweeps around. But that's not just blowing off of there. You can see it's squirting out. These are squirting out. You know why they're little ones? Because these are blood vessels. That's an artery. That puppy there pumps blood like crazy. These little things squirting up into every little cell. Now, the tendon enthesis has almost no blood in it at all. Very, very lightly, very little blood in there, just put it that way. And also the tendons. The tendons have almost no blood in them. They are just a strappy, tough material, just like this is. These are anchors, and the tendons are just enough of a tension thing so that you can it gives your muscle a little bit of support as it pulls away from its anchor, which is this. You have to understand chemistry, you have to understand biology, you have to understand what's out in space, all the particles are in space, you have to understand light and why is light cooking that. You see that monster I was showing you? Now it's no longer in the direct sunlight. You can see it very nicely. 40 meters wide is this length. So you got 40, 80, 120, and somewhere in there. Let's say 120 meters. That's in feet. That's like 360 feet, something like that across here. That's just absolutely enormous, 360 feet. And that is an artery. You see all these little balls here? Those are the blood vessels. Those are the little things that send the blood in to all, because every single cell has to have blood. I mean, there is a bazillion little blood vessels in your body that are so small you almost can't even know they're there. But in this, because this is 120 or 360 feet across, we're looking at something you couldn't see in any microscope that we have now. So they call them dragon balls. And they gas off as soon as it hits the sunlight direct. Now this thing is huge, Comet 67P. That's Raleigh, North Carolina, downtown. This is 67P. That's the size of it. I think the bone must have come up through here, and this is the muscle that wrapped around the bone, and then you get down into the anchor, and it could be a heel bone. I'm not sure. I don't know. I'm not going to make any assumptions of what it is, but it is an anchor, and it does have the tendon, and it does come up to the muscle, and then it went somewhere from there. Where, I do not know. But this would be a bad day to be in Raleigh. All right, these are the tendons, and they landed right down here. This thing is taking his pictures. You see these? If you understand the fibers of tendons, you will understand what you're seeing here. I understand it because I study it very, very deeply. 200 meters is that wide. 200 meters. That's just unbelievable. That's 600 feet is here. So we're, I don't know, what do we got? 600, 1250, half a mile up there. This is just absolutely enormous. And these are the tendon fibrils. Now look closely at them. This thing does not focus well, but if you could see, there's fibers here. If you know how to look at it. And then you see the muscle bundle on the side. And then this is nothing more than eroded bloody flesh. And the spectral analysis is conclusive. This is biology. And they say, yes, absolutely, no questions. Organic is biology. We have no explanation. See you later. Have a nice day. That's what happened. All right, this 67P again. It ripped out of something because it would have been right here embedded into something, the flesh. You see these little bumps? Those are the grabbers that hold this thing in to whatever it was attached to. I don't know what it was. But you can see, how intense the sunlight is here? And it's just boiling off. Biology. Gases. All right, those are the blood, those are things that are why they smell steak in space, because of this. Now, this is just a little collage, but you see these? This is Mimas, Tetchus, all the different moons, I say, could very easily be body parts. You saw how that wrinkly stuff was. Let me show you what a tendon looks like when it attaches to its filament there. Now, this is just a collage, like I say, but then you got Iapetus, who has this equatorial ridge. They all have biology. And it's the same biology as here on Earth. It's absolutely enormous. And all the ancient texts talk about this. So this is where everybody goes crazy. Oh, the guy's nuts. He's just insane. No, I'm not. I'm looking at the facts. If you could just turn yourself away from material evidence, then you are not a scientist. Okay, once again, get yourself an anatomist. This is a finger, and that's Oumuamua that Avi Loeb was testifying to Congress or Senate or somebody about this could be an alien spacecraft. No, it's a finger from some gigantic creature. Now, how can I say that? Well, here's why. Let's start with the tip of the finger. That right there is what's called grip skin. You see that? Little wrinkly stuff that at the very end, it's like a layer. That is the layer that's on your skin too. And I will show you it's on my mud fossils, which I had DNA tested, and they are human. Now, there is an apical tuft. Get a good top quality anatomist, which I did. Several. 100% agreed. This is a finger. This is where the anchor of all these little straps come out of this. And here's one right here. This is what it is right here, just like that. It sits right at the end of your fingertip. And all of these balls anchor in there. You see these little straps coming out of there? Then it runs a tendon strap right down here to the joint in your finger. It's right there. And that joint, all of these little straps invest in these little holes here. Hold on. They're just like this. All right? All of those little things, the tendon comes down and it locks in there so that it can do this kind of stuff. Then on the other side, you got the same thing, another one going this way, because that's the crook of the bone. It's right there in between the two. And all of these little tiny tags tag in here and tag in here. That's how it's held in. Then this one runs down right to there. And that's the black is the artery, the vein. And this side would be the artery. And this right here runs right over the top of your knuckle. It's this way, but this is the top. And that's where the tendons lock in. See the tendons up here? That's where they lock in to make your finger go up and down. That's a fingertip. And everybody says, oh, that's just an artist's illustration. It's better than an artist's illustration. This is done in a manner called shadow photography. What happens is if this is just bright on one side, all you can see is that bright. But as you turn it, you see all of those features show up. And then you turn it some more and some more and some more. And you see all of the features show up when you turn into the different, like even the neck. You can't see anything there. Well, maybe you can, but the neck is right here. And as you roll it around here, sometimes it doesn't show up at all. It's nothing at all whatsoever. And sometimes once you hit the correct shadow, you can see exactly where the neck was and where the center of the neck was and where everything. You can see everything. You can see all the dimples. That's what this kind of photography is about. So don't tell me this is just, oh, that's just CGI, this and that. I get so many people that have no idea what they're talking about, and just throw out all these statements. And these are the people that should have an idea what they're talking about. That's the problem. Well, not all of them, but most of them. Now this is Ison, Comet Ison, and that one there I could go with a possible spacecraft. I have no clue about that one. I don't think anybody does. See, this is what it looks like, and that's when they dim it down somehow to see what's illuminating everything. See, there's Comet Hartley. It's a chunk of bone or something out there. There's 67P again. I think that is either a tendon strap that's coming down. I believe this is a ankle, and it goes up to the leg this way. I'm not sure. I got to be honest with you. I have no clue. All right, let me just show you this. This just shows you that it shoots out here from wherever the tube is facing. It's not just blowing through there and everything's blowing off. They're shooting out of the tubes. I've shown that pretty clearly. You see that? That's asteroid Psyche, they call it. That, I'm telling you right now, is a heart. And I have one here, a heart, that has exactly the same architecture. These are the two main valves in the heart, and then there's a little pincher up above in the middle. I have it here, and I showed it clearly several times. This is almost solid metal, and that's exactly what happens. And that's why metal asteroids and meteorites are from blood products. And obviously the heart is almost saturated, 100% blood. Then you got your livers, and then you got your lungs. Those are the ones, and I have 3 iron lungs right here. See these little, those are 3 tiny little meteorites. And they're iron. You see the magnets on them? They're iron meteorites, but they don't smelt off like the big boys. The big boys are pushing really hard through space, and coming through our atmosphere, they just cook off and turn into solid chunks of iron. And I'm going to show you that right now. But they still have blood inside them. You think I'm wrong? Watch. All right, you see what they're? They're up on a chondrite, and these are the chondrules. And that's what they're looking at, is these 2 different places. They took one, it had different material than the other. They took 2 different, and these are, they're saying, oldest material in the solar system. I don't know how they come up with these claims, but they do. But I can tell you right now, that is an artery, and that is more likely a vein. You see that? That's an iron meteorite. And the reason it's all solid iron is because it was big enough and heavy enough, and coming through the atmosphere was dense enough to smelt it, which means it boiled it off to a certain temperature. All the cheap stuff goes and the metals remain. And every one of these different crystalline patterns is a different type of metal. You see that and that right there? Let me show you what those are. This is an iron meteorite. Where would blood come from in an iron meteorite? You see that? That's that iron meteorite. All these different patterns and crystallizations are different metals that have congealed together as this turned into a hot blob of molten material. Now, what material? All the cheap stuff burnt off. That's why you see all these smoke trails coming down there, and they come. All that stuff is burning off because it's just not structurally strong enough like metal is. Well, what happens here is we can see that these were the artery and the vein. You see that? The black one, that's the vein. Black is always the vein, and it's the FeO2 blood. This is the FeO3 blood, is the red blood. And I'm pretty sure you can see that. That's pretty red. And that should not be in the center of an iron meteorite, and neither should that black spot, wherever that is. Oh, it's out of frame. Hold on one second. There it is right there. that's blood. Now, that's because it came through. Now, my iron meteorites right here, all three of them have blood in them. I mean, raw blood. You could actually, I'm sure, sample it. There's no question. It's reactive to hydrogen peroxide, which is the enzymes which are still left in here from life are reacting to the hydrogen peroxide. It's called catalase. It cuts off an oxygen molecule, and you see them all bubble up. And I can show you right inside, like all the these holes and everything. And I'm going to show you something in a meteorite that's on display down in New York or somewhere. I don't know where it is, but it's on display, showing these blood vessels. And I'm sure they'd go get blood out of it right now. It's one of the biggest meteorites on Earth. All right, you see this? This is one of the biggest meteorites on Earth. That right there is the blood vessel of one of the alveoli holes. And it's exactly like this right here. You see that? The exact same thing. This is this big crater. And that hole right in there is this hole. This is a lung. Didn't come through space, but it's a lung. This one came through space. You want to see the whole lung? Watch this. That is that iron lung. And that right there is that little hole I just showed you. But I could see red spots everywhere around here. And if it's red, there's going to be some blood in there somewhere. You see, that's the spot I was showing you right there. That's the little blood vessel. Well, not little, it's huge. That baby there pumped a lot of blood. And that's a lung, and it came through space. And that's why it's all smelted off like this and burnt off. It didn't explode. And a lot of times they'll explode and they'll just come into pieces. This one, for some reason, stayed together, but it completely vaporized all of the gooey, nasty stuff and zip, gone. And what do you end up with? This basically is what you end up with, only it's now is iron. All right, this is the lung, same thing. They have all the alveoli. I see all it's identical, only it didn't come through space and it's a little bit smaller, tiny bit. Now let's look at these. Whoops. Let's look at these in the microscope, and I'll show you them bubbling off blood. There's blood in those, and those are meteorites. And if anybody has a meteorite, you can easily test it. If you have meteorites, you're going to be able to find some blood in them somewhere if you look close enough. They all are body parts, my friends. I'm sorry, we live in a biological universe. I can't find anything that's not biological. Moons and everything. You want to see what a moon looks like to me? I'll show you. You see that? I've shown you things that are just hard to deny. Comet 67P, all the rest. This is a moon. I think this is Mimas or Tetris. They all are very, very similar. Some of them have just so obvious where they broke off the stalk. You see this? That's the stalk right here. This is all the wrinkly looking stuff that's all over. Those aren't impacts. Those are the divots that hold that thing inside of a piece of meat. That's why space smells like meat. It's loaded with it. Meteorites are a lot meatier than we thought. Okay, that's Mimas. That's a moon. I'm not sure. I think it's I'm not sure which planet. Boy, I gotta look that up. Okay. This is Mimas. It's a moon of one of the planets. All of the ones I'm going to show you are moons of our planets that are in our solar system. And they're going to have a very similar look, most of them, even our moon. Now, let's see what we see on the next one. So what you want to look for is these craters. Now that's Tetris. You see, this one also has craters. You see this one here? Now, that's Tetris. Now, this is Iapetus, who has an equatorial ridge. You see that? Some of the tendon balls, and these are tendon balls that are in your body, and some of them have ridges. The ones on Earth, the same thing. The same thing in your body, some of them have ridges. Now, this is Iapetus, and there's the ridge, and here's and the ones with the ridges have two different entry points. And it is what it is. Okay, so I would agree that this is groundbreaking. New analysis unveils true nature of ancient asteroids. Well, where did that life come from? It's saturated in the universe. As far as I'm concerned, everything is life. Even the planets. Jupiter is about ready to give birth. I showed this the other day. It's just startling, to be perfectly honest with you. Okay, so I would say this is groundbreaking, astounding. They realized that the asteroids are biological. Sounds to me that's what they're finally realizing. So I agree with Michelle Starr. Comets could easily deliver life to anywhere. So can asteroids. So can meteorites. We got a little thinking to do. Where did it all originate from? And is everything, literally everything, made of biology? It appears that's way to me. Okay, this is the terrestrial lung. This is the meteorite lung. This is that cavity right here. You see that with the hole in there? That's the one that I showed you with that gigantic iron meteorite. Now, things you want to consider here. This one here bleached everything out of it, and I don't know what condition it was in, but everything was removed except the structural collagens. Very, very unusual. This one, I don't want to move it because it's in the microscope, but this one here, it burnt up. It was wet when it came to space. It burnt up, and I can still get blood out of here right now. I will show you in the microscope in a second, because I do have it in the microscope. It's up there, but you can't see it well because I need to turn the lights off. Now, but you can see these two are basically identical, and they have the same holes and the same as that big gigantic one, the big iron one. And I showed you the blood in all the meteorites. I showed you all the moons. They look like body parts. It's time to investigate this with a serious eye. Okay, before we get started, this is a terrestrial human lung, and it's DNA tested, CAT scanned, the whole 9 yards, no question what it is. And it still has the pleura, which is the coating that wraps the lung. Now, this is a human lung. Well, I don't know if it's human, but I'm pretty sure it is. I didn't have this DNA tested, but this one here leaked blood out of it when it came out of the mud. And that's the blood that actually came out of these little red spots. Now, all of this is alveoli. You see these little round holes? They normally would be open and your air would go in there. All right, you see all those? Well, these are all filled in. They're here. They were all here, same as these here. But they filled in with quartz. And that's what happens, is voids fill in with quartz, silicates. And this was all voided out. This one's going to be a void one, similar to this. You know, I just showed you this one here. Hold on. This would have been just like this, except it filled in with quartz. And that's because it was in a wet environment, and the quartz, like this has some quartz are starting to grow in here too. I actually showed the quartz. Actually, I could probably show you in a microscope. But anyway, this would fill in with quartz eventually if it was in that condition. That's what happened. Now, the other one, totally different situation. This one was in some other condition. There's a lot to think about here. But I can tell you what, this is preserved so pristinely that it's almost like the actual living pleura that is in these types of tissues right now. Now, what I am going to show you in a microscope is this lung right up here. Hold on. Remember this though first. Remember what this tissue looks like. You see all those little white flakes and stuff? When this other lung came through space, everything burnt off. Some of the white flakes remain, but most of the other stuff burnt off. You see how it's all blackened where the other one had really all fibery looking stuff? Well, now, this little hole right there is where the entry to the lung is. This is the lung, my little iron lung. Iron lung. All right, now, what are we going to do here? We're going to put some catalase in here. And I'm going to see, catalase is the thing that reacts with blood. Or actually enzymes, but enzymes are in the blood. Because an enzyme is such an absolutely elegant molecule. There's no way in the world an enzyme is going to just appear from nothing. It is a product of life. So if this shows catalase reaction, which is a bubbling, separating the oxygen off of the hydrogen peroxide, it's H2O2. It'll turn it into H2O, and then an oxygen will bubble off. Let's see if it happens here. All right, now it's going to maybe take a few minutes, because this came through space. And when you heat up any enzymes or any bodily tissues, at a certain temperature, they just stop, it denatures them, it destroys them. Now, this I don't think got up hot enough to destroy the enzymes. We're going to find out in a second. So here it goes. I'm going to fill that little hole up with catalase, hydrogen peroxide. If we see a lot of bubbling, we'll know. And I'm seeing it right now. Watch down here. You see it coming out of the hole? Watch it there. Let me come down on it a little closer. So we already, that's a quick reaction for a meteorite. I've done a lot of meteorites, and they all react. See it? Look at the stuff coming out. Look at it. Look at this. Look at that. Whoops, you can't see it, can you? All kinds, all this stuff came out from here. Look at that. I'm going to put some more in there. It all pushed out, and I think it's already absorbed all that. Look what's coming out of there now. That's that hole that goes deep inside the lung. There could be something living in this lung. I thought I found one the other day. Something came squirming out of there. Look, watch what's going on there. All right, now the catalase is going. There goes bubbles. The bubbles will start coming out. Keep your eye on that area right there, because that's the hole. There it goes. Some bubbles are starting to form. Bubbles over here too. See them bubbling up? Anywhere where there's blood, and the blood has the enzyme, and the enzyme, like I say, is exotic as hell. They are just not laying around here and there, those enzymes. This is the reaction you would expect. It's not as intense as like a living, one that was just recently dead, or an earth lung. But you can still see that look, there comes the bubbles. When you see those bubbles, give it a minute here, because it took about 5 minutes, I think, before it seeped in and got past the, what the hell is that? That's just what is that? That's just some kind of hair or something. I think. But you could do this at your own house. Now let me come right down on top of it, because sometimes you can't even see. Those are bubbles. These are all little tiny bubbles. They're so tiny, you can't even see them at that height. And I don't know if I'm going to be able to get down to them close enough to see them. Sorry, I just can't get there. Yeah, this is, whoops, now you can see them. See? over here. See them bubbling up over here? I'm getting a better reaction here than I am there. But we are getting a reaction both places, no question. Up here, anywhere where there's raw blood, you're going to get this bubbling effect. And that is strictly due to a biology. It's the catalase. If you don't have the catalase enzyme, you're not going to get that effect. It's just not going to happen. You know what, we're not close enough. Let me get a different perspective here. I think maybe I can get closer. I may have to hold it in my hand, and it'll be a little wobbly. Alright, let's take a look now. Let's see if we can find that thing. Oh, this is very, very time consuming. This is where this catalase reaction is happening. You're seeing a little bubbling here and there. You see it bubbling up, the bubbles are popping up. And it may start to really kick off too. Like I say, this thing came through space. It cooked up. That is, as soon as you overheat an enzyme, it stops it from doing its job. And if all you got to do is change one little molecule in that catalase, and it just stops working. It won't break the oxygen off into those little bubbles. You see it? That's the reaction. Anyway, that's about enough of that as anybody can stand. Alright, this is a terrestrial fingertip, and so it didn't come through space. Let's see if we can get a catalase reaction out of this. There it is right there. You see it? When they don't come through space, they get a really good catalase reaction where there is enzymes. And that must be where the enzymes collected, you know. You see it? That's exactly what you expect to see. That's the catalase reaction. When you see it in that, this is good, clean, red blood. I think it probably leaked out of here. That looks like a little red blood area. Anyway, it's going to be all over this area, I would think. See it bubbling up over here? This whole area is saturated with red in blood vessels. And there's that catalase reaction. That's what you're looking for to show the signs of biology. That's biology. So it's not. Catalase is so elegant of a molecule. There's no way in the entire universe that it could develop all by itself. So what's transferring these biological bits and pieces from comets to planets? Where did it come from in the first place? I'm telling you, as far as I can determine, there is nothing that's not biology. 100% of everything I can determine is biology. it's stunning, I know, but it's, if anybody can prove me wrong, prove me wrong.